7x cubed plus 7x squared plus 2 over x squared plus x. So remember we said we had to take the denominator and factor it. And let's just deal with the fraction part first. So this will be equal to a over the first one plus b over the second one. I'm going to multiply both sides by this denominator. There we go. Which will cancel this fraction. So x plus 1. Sure. So be x times x plus 1 times 7x cubed plus 7x squared plus 2 times a over x plus x times x plus 1 times b over x plus 1. So these will cancel. One of these will cancel. X plus 1 is gone, so we'll be left with 7x cubed plus 7x squared plus 2 equal to a times x plus 1 plus bx. Right, because this x will be times that b, a times that. So on this one, you can do Heaviside method to find your a and b real easily. But let's do it the other way because this other way works every time, equating the coefficients. So this will be ax plus a plus bx. All right, one moment, please. Okay. So take anything with an x on it. Now equate it to anything with an x over here. So ax plus bx equals to, there is no x there, and a is equal to 2, which is the constant. We don't really need the x though, but this is the x terms. The way we should think about it is that these are the coefficient and then there's an x here. But after a while, I think we just kind of just worry about this. So a is 2, then b has to be negative 2, right? So now instead of integrating this guy, I will integrate 2 over x dx. Forgot to write that. Integrate that guy, I'll give you 2 ln x plus negative 2 ln x plus 1 plus c. Oh, shoot. Made a mistake. I forgot that the denominator has a higher degree. So I need to redo this whole problem. Very sorry about that. So all this is fake math right there. That's what that is. All right, start over. I knew it felt too easy. Well, too bad. All right. So What I'm going to have to do is divide this guy into this one before I do anything. And I gotta have all the descending degrees or powers in order to do so. So here will be my scratch work. So 7x cubed divided by x squared is equal to 7x. So that'll be my answer for the first part. Then you multiply 7x times x squared plus x, giving me 7x cubed times 7x squared. And then they're both positive, so I gotta switch these signs. So this gives me 0, 0, 0. Looks like that's all I can do. Interesting. So this question here, I don't need this anymore. The integral of 7x cubed plus 7x squared plus 2 over x squared plus x dx is equal to the integral of 7x dx plus the integral of the remainder over the divisor. So this piece will require a partial fraction. This is no big deal, right? That would be just 7 halves x squared plus the integral of 2 over x squared plus x dx. So I'm going to have to change this fraction using my partial. Right. Multiply both sides by x plus 1 times x. This will give me 2 equal to x times x plus 1 times the a over x plus x times x plus 1 times the b over x plus 1. So that will give me 2 equal to a times x plus 1 plus bx. So very similar to the last one we did. So when we equate these coefficients here, we get, let's see, similar system. So we get a plus b for the x terms equal to 0. A is still equal to 2. So b is equal to negative 2. Okay. So now back to this piece here. So this will be equal to plus the integral of a over x dx plus the integral of b over x plus 1, which is equal to the integral of 2 over x dx plus the integral of negative 2 over x plus 1. So finally we're done. That would give us 2 ln x minus 2 ln x plus 1. So the answer was close, but not quite right. Is there any questions on this problem? Is the division okay? The long division, does that make sense? Did the long division giving us these two integrals make sense? And then doing the partial fractions to get these 3 integrals. Is there any questions about that? Okay, so the other two will be different types of uh, partial fraction problems. So let's move to the improper since we just did those. Um, okay, so this one will be integral from 6 to infinity of dx over x squared minus 25. One second. Okay, so remember we said that a point is basically just a section to help you deal with the infinity. It's more of a notational kind of thing. So solve this integral. This will be x plus 5 times x minus 5. Sadly, this looks like a by parts kind of question. So, okay. So during the 8-point intersection, any kind of integral can pop up. So let's deal with the partial fraction step. They're equal to a over x plus 5 plus b over x minus 5. So multiply both sides by this denominator. That will leave me with a 1 over here. Skip a small step here. Let me know if you have a problem or if I confuse you. I'm going to show the cancellation over here just in case I did not show it on the left. So that leaves you with x minus 5 times a plus x plus 5 times b. So that gives you ax minus 5a plus bx plus 5b equal to 1. That's there the whole time. So we equate the coefficients. So I'm going to take anything with an x and set it equal to any x coefficient over here. There is none. Anything with a constant equal to a constant. So solve this system. You can use a matrix or whatever you want. Just because I'm lazy, I'm going to multiply the top equation by 5. And then I'm going to add them together. Usually I do matrix, but this one's pretty easy, right? Since they're the same factor. So add them up, gives you a 0. Add these up, gives you a 10. So this gives you a 1. So B is 1/10, which means that A is negative 1/10, right? So this integral up here is actually going to be the limit as B approaches infinity of the integral 6 to B of 1/10 over x plus 5 plus negative 1/10 over x minus 5 dx. So let's do that over here. I'm going to go ahead and pull out the 1/10 because that looks weird. So 1/10 will be outside over here just waiting. Now even pull it in front of the limit because you're allowed to. So now I have the limit of 1 over x plus 5 minus, I should put my dx, minus 6 to b of 1 over x minus 5 dx. So these integrals are just going to be ln types, right? Nothing, no big deal here. So you're going to have the 1/10 waiting for you again, waiting for you to take the limit. This integral is simply ln of x plus 5 minus ln of x minus 5 from 6 to b. Okay. So plug in the value, so you'll get 1/10 times the ln of b plus 5 minus ln of b minus 5 minus, that looks ugly, let me fix that. Minus ln of 6 plus 5 minus ln of 6 minus 5. Okay. Do you see why this is 0? Or possibly. Or is it? Let's see here. Yeah, it is 0. Which will then give me negative. My answer differs by a sign. Let me see what's going on here. Oh, shoot. I made a small error. We said that A is negative 1/10, right? Not B. Check it out. This should be negative here. This should be positive. Okay, that will change only a small part here. So I'm going to factor a negative 1/10 to make this the same. Negative, negative. That we don't have to worry about changing anything else. Okay, so now we're good. So let's turn the page here because I'm out of space. So we got negative 1/10 times ln of b plus 5, b minus 5, okay. Oh, dang it. I forgot to write the limit. Over here we had 6 plus 5, 6 minus 5. Okay. 6 plus 5 minus ln of 6 minus 5. Okay. So the reason why it's 0, I feel like you might not see it, is because you can combine this log, right? Because it's the same base, meaning I can combine it into one log of b plus 5 over b minus 5, right? Minus ln of 11 minus ln of 1, which is going to be 0, right? When you take the limit, these will outdo each other, giving you a 1. So this will go to 0 because you'll end up with just a 1 inside when you take the limit, leaving you with finally just a negative 1/10 times negative 11, negative ln of 11. Which is 1/10 ln 11. Is there any questions as to why that is or what happened? So since it has an area or a value, then you would say it converged or does not diverge. Okay. Do you have any more questions on the review? Is there anything else that you struggle with, or you guys feel okay about it? Any questions from your homework? Okay. Which one is giving you issues, Garrett? Stupid thing. Hold on, sorry, my computer's being really annoying. It said number 3, 8.4. Okay. Eight point four, number 3. It's the integral of the square root of 81 minus x squared dx. So this looks like a sine type. So rewrite this into, well, I'll do it down here, I guess. Of 9 squared minus x squared dx. All right, so my A is 9. So we're supposed to use the x equals a sine theta, which means that x is equal to 9 sine theta, where dx would be derivative of this, 9 cosine theta d theta. Okay. And this right here in the middle implies that sine, if you solve for sine, is equal to x over 9, right? So this will help you build your triangle right there. You can also use the ones I gave you, the definitions, but I like to just build it myself. Solve for sine, so opposite over hypotenuse. It's right there. Solving for the missing side will give you 81 minus x squared, which is what we wanted to see, right? Because that's going to be this. So let's do our sub. This will be x is equal to, so this will be 9 sine theta. Dx will be replaced with this in a second. Square root of 9 squared minus 9 sine squared times 9 cosine theta d theta. Okay. You cool with the sub so far, Garrett? All right. So now at this point, we just got to do some math here. Some algebra, I guess. Sorry. So this would be 9 minus 9 squared minus 9 squared sine squared theta times 9 cosine theta d theta over 9 sine theta. Okay. So factor out a 9, you'll end up with the square root of 9 times 1 minus cosine squared, which is what we want to see because that will be replaced with a sine squared, right? So this is still 9 sine, whatever. Okay. So then this comes out, so I'm going to change it to sine squared. So I'm going to have square root of 9 sine squared theta. Okay. Yeah. Times 9 cosine theta d theta over 9 sine theta. So this becomes 3 sine theta times, this 9 will cancel, right? So might as well do it. Cosine theta d theta over sine. So these signs are gone. So finally, we're at integrating the 3 cosine theta d theta, which is simply 3 sine theta, right? Plus c. So this would, so sine, I'll get back to x. What the hell is sine? Well, that is defined as x over 9. So that'd be 3 times x over 9 plus c. So that reduces to x thirds plus c. Did I forget anything? Double check. I feel like I forgot something. Oh, shoot. No? No, it looks legit to me. Hold up. X is 9 sine. $89 squared, so factor 9. Oh, shoot. Should be factoring 9 squared here. So this is really a 9. One mistake. Yeah, that's fine. There's an X down there. Yeah, I didn't get their answer at all. Not even close. There's something missing. Oh yeah, I think I got overzealous there. Shoot. This was sine, and I magically changed it. Thanks. There's the issue. Okay. Yeah, I mean, can I fix this nicely? Nope, cannot. I was like, that was too simple. Something's wrong here. So this would become cosine and then come out as a 9 cosine theta times 9 cosine theta over 9 sine theta. I think. Yeah. Yeah, there we go. That's better. Thank you. All right, so now we got one of those 9s are gone. We'll have 9 cosine squared theta over sine theta d theta. At this point, no, I'm gonna have to do identity here. Pull the 9 out. It's just no way. This is 1 minus sine squared theta over sine theta d theta. So that would be 9 times 1 over sine, which would be cosecant, right? Let me show the work. Here. Separate the fractions to get 1 over sine theta minus sine squared theta over sine theta d theta, which will give us, still haven't integrated yet, integral of cosecant theta d theta plus integral of sine theta. Just go ahead and put the 9 there. So integrate these two. That will give us integral of cosecant. I think that's negative ln secant plus cotangent, I think. Let me double check. Is it negative or positive, Garrett? There's a plus in the middle, right? Yeah, there it is. Okay, so we have a negative 9 ln cosecant theta plus cotangent theta. Integral of this guy would be -9 cosine. Plus cu, whatever. So then you bring everything back to x. So we have sine. So cosine theta would be this nonsense. Cotangent theta would be this nonsense. So plug all this in. Cosecant is just 1 over sine, so we can just flip this one over. So we're going to use these to complete the question. So finally our answer will be -9 ln of 9 over x plus square root, sorry, not on the camera, plus 81 minus x squared over x minus 9 cosine, which is square root of 81 minus x squared over 9, which cancels this guy, plus c. Okay. Sorry about that mistake in the middle. Is there any questions about any of the steps? Does it make sense? Okay. Yeah, I highly recommend you build a triangle as soon as you start getting x and dx set up, right before the sub. Okay, the other one is number 8 on 8.3, you said. Okay. Looks like one of those secant tangent things. Okay. Okay, so they have the integral of secant squared x over 10 times tangent of x over 10 dx. Alrighty, so it's going to be one, I think it's from, maybe I gave you those strategies for factoring a certain way and then introducing a certain sub and identity. So let me think here. So derivative of secant is secant tangent, right? So what we could do, I think this might work, is break off a secant and use this secant tangent as my sub part. So I'm thinking let u equal secant of x over 10. Du would be secant x over 10 times tangent of x over 10 times the derivative of the inside, which is a chain rule, right? There is no 1/10, so 10 du is equal to secant x over 10 tangent of x over 10. Oops, 10 there. So the integral will simply be just u 10 du, right? So that would be u squared over 2 plus c, giving me 5u squared plus c, which is actually 5 times secant squared of x over 10 plus c. So when you're doing these trig types, you gotta try to see if the du and du are already in the question, and if it's not, factor out a secant or bring in an identity to help you out. So if you see sine and cosine, then that's probably going to be your u and du. You just need to set it up accordingly. And I gave you those guidelines. There was like, I think like 9 of them to kind of guide you if you don't see it right away. You guys have any other questions? Did this make sense, by the way, before we move on? Yeah, I thought it was harder at first too. Then I'm like, wait a minute. Once I saw the sub, it was kind of basic, right? You guys, anyone else struggling with anything, or you guys doing okay? All right, guys. Well, if that's all, then I'll see you guys later. We'll start chapter 9 next time.